So now in this video, I'm just going to do a quick demonstration, and I really kind of got to show you more than explaining. So first off, we basically have two parallel circuits right here. Now when I removed the capacitor, they are not parallel circuits anymore to do the first part of the demonstration. So I'm going to connect negative over there, and what we have is a couple polarity indicator circuits right now. So we got the left one right there, red LED because the positive is up high and the negative is down low when it comes to the position on the breadboard right there. Now if I take the black jumper off and put the red jumper here, so this is the more positive side of the power supply right there. Now you can see that we got the blue LED that lights up when I put current that way. Also, it'll be blue when we put current that way. So that's the first thing to know about this. By the way, this is a 12 volt. I got the power supply set to 12 volts, and these are 1000 ohm resistors. So we're going to get 1 milliamp of current for each volt across the resistor. Remember, LEDs drop some of the voltage. So now the capacitor that we are using is a 1000 microfarad capacitor, and that lets you know how much charge it takes to raise its voltage basically, and how much stored charge it has based on the voltage in it. We could go up to 35 volts, but we're just working with 12 volts here, mainly because that's about the limitation of the LEDs. This side has to be more negative, so we can't really swap polarity anymore when it comes to the power supply once we insert the capacitor right there. So you can see the positive side of the capacitor is to the upper jumper right there. That's the side that has to be charged positive. And the negative one is sharing the same row. Actually, I'm a row off. Now that I look, no, that is the same row. It just looked weird through camera. Sharing the same row as the resistor right there. So now I have already connected the negative side of the power supply to these header pins. These are called header pins. There's longer pins going into the board, and so each one of these pins is going to the same row. So the two pins coming up are part of the row now, and we'll zoom back. I don't know why, we don't really need to now, but in case, I'm going to connect right here, and you can see both red LEDs lit up, which makes sense. This side's positive, and that side's more negative, as we saw before. But now you can see this one turned off. That's because the current that was going through the LED was also charging the capacitor. And so we had current going this way, and we also had current going that way. That makes these two circuit fragments parallel right there. But now that the capacitor is charged, it's got the supply voltage other than the LED drop that it charged to. And so once it equals the voltage across the resistor as the power supply voltage across the resistor, current stops flowing. That's why that red LED stopped lighting up, and it faded off as the capacitor was charging, because the voltage difference was getting smaller and smaller across the resistor until there was basically no voltage difference, and thus no current flowing through that LED, but current can still flow through this LED independently, because this circuit fragment is parallel to that circuit fragment. So now we're finally going to get to the part of the demonstration that's important for this video here. We got a negative there, positive there, current flowing right there, but the capacitor is charged. So I am going to remove these both at the same time. We could just remove one or the other, wouldn't matter. But there you can see blue LEDs are brighter at lower currents. These two LEDs have the same amount of current flowing through them. But right now, the capacitor there is the power supply until it finally runs out of energy, where it can't even light the blue LED. That red LED has a faint glow, as you can see there. It's just not as bright as the blue LED at a specific current. So what's happening is, now this is the negative side of the power supply. That's why that blue LED is lit up. That's more positive, that's more negative for this LED. But when it comes to this one, that's more positive up there, more negative there. So more positive working towards more negative. When it comes to capacitor, it's always important to remember that they will alternate current depending on whether they are charging or discharging. And they can alternate because right now this is the power source, and now we're switching where the power source is. Now the capacitor is the power source. It's actually the only power source. It's not feeding current back into this power source, but it could if you had a power source that goes up and down in voltage. Right there. We're not going to worry about that. The main takeaway is that right now, because this came up in a comment, right now these two circuit parts are parallel. They got positive on one end, negative on the other. It's the same voltage. That's what's most important about whether it is actually parallel. This is kind of parallel to this over there, but it also has the capacitor. So these two resistors are not parallel. Even the two resistors and the two resistors in each resistor's LEDs are not parallel because we also have the capacitor. The capacitor, resistor, and LEDs there are parallel to the resistor and LEDs there. For it to be parallel, it has to be the same voltage across it, which is 12 volts total right there. All these don't have 12 volts across them. All these don't have 12 volts across them. They're splitting them up, but there's a total of 12 volts across these two circuits from the same power supply. That makes them parallel. Now, when I could remove one or the other of these, doesn't matter, right there. Either way, it cuts power from the power supply. Main thing is though, once we remove the power supply, these circuits, it's one circuit now. It's not parallel at all. This is all series. I mean, these two LEDs are parallel because it's a polarity indicator. You need parallel LEDs. But the circuit as a whole now, it's just one circuit and it's series. So this is actually more positive there, working to more negative as long as it has power. So we have a circuit here where sometimes it's parallel, sometimes it's series. It all depends on whether we're cutting or providing power from the power supply. So in any case, I just thought this might be a helpful visual demonstration for anybody that sees circuits like this, thinking that just because resistors have basically the same path, headed in the same direction, that they're always parallel. It's not always the case. It may even be kind of like this circuit where sometimes it's a parallel circuit, sometimes it's a series circuit. There's changing things. So yeah, that's really about it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.